All right, welcome back. We're going to do the substitution method. So this is how you solve the equations, the system of linear equations without a graph. Okay, so as you can see, there's no graph here. So here are the steps written out for you. The first step is to solve one of the equations for one variable. The second step is to substitute the expression from step 1 into the other equation. Step 3, solve for the remaining variable. Step 4, substitute the results from step 2 into the new equation from step 1 and solve. Step 5, write the answer as an ordered pair. You are probably thinking, Ms. J, you just word vomited and I have no idea what that means. That's okay. We are going to get started to do it together. That's why we're here. Okay, so step 1, solve one of the equations for one variable. So that means check or make sure that either x is by itself or y is by itself. If it's not, solve it so that it is. In our case, we are lucky. Y is by itself. So step 1 is automatically done because that equation is already solved for y. That equation is solved for one variable because it's solved for y. Y is by itself. Step 1 is done. Let's do step 2. Substitute the expression from step 1 into the other equation. Okay, so step 1 is done. What it means to substitute is, since this is your y value, that means negative 2x plus 11 is equal to y. And you're saying, yeah, that's what it says. Okay, cool. So then where it says y in the other equation right there, we're going to replace that with negative 2x plus 11. So let me show you. We have 8x minus 2. Okay, here's where the y is. I'm not going to write y anymore. I'm going to write negative 2x plus 11. Where did I get that? Well, y is equal to negative 2x plus 11. So I don't have to write y. I can write negative 2x plus 11 because they're the same. Okay, then we just finished writing out the top equation, so it's equal to 14. So all I did was I just rewrote this piece right here. It's the same thing. 8x minus 2y, except this is our y now, equals to 14. Okay, so that is step 2. We just substituted the expression from step 1 into the other equation. We substituted this piece into the y. Okay, now step 3, solve for the remaining variable. All right, what variable remains here? I see an x, I see an x. Oh, okay, so that means only x is here. We must solve for x. So let's do that. So to solve for x, we're going to first distribute. We get 8x. Negative 2 multiplied by negative 2x is going to be plus 4x, because a negative times a negative is a positive. And then the negative 2 multiplied by the 11 is a minus 22, and it's still equal to 14. So all I did was distribute. Then let's combine the 8x plus 4x because that can be combined. They are like terms. That gives us 12x minus 22 equals 14. Now to solve for this, hopefully it's starting to look familiar. Add 22. Once again, trying to get x by itself. Those cancel out, and then is equal to 36. And then you're just going to divide by 12. Why do we divide by 12? Because x is being multiplied to 12, so you do the opposite. We divide by 12 so they cancel out. X is equal to 3. Okay, and you're like, oh, am I done now? No, that was just step 3. We solved for the remaining variable. We solved for x. We are not done yet, but we're really, really, really close. Step 4 says, substitute the results from step 2 into the new equation from step 1 and solve. So we're going to, essentially what that means is we're going to take this answer, x equals 3, and to plug it into the first equation, that where we got the variable by itself. Remember, step 1 says, solve one of the equations for one variable. So that means we're going to plug it into this one. I don't want to scroll, so I'm just going to put a line there. We're going to plug it into this equation. This one. I'm like, how do I point when I'm not in person? This equation. Okay? And why that one? Because it tells you what y is. If you plugged it into the top equation, sure, you can still solve for y, but it's less simple. This one's easier because it already tells you what y is. So let's plug it into this. y is equal to negative 2x. Okay, where is the x? X is 3. So negative 2 times 3 plus 11. This would give us negative 6 plus 11. And then we add that together, and y is equal to 5. Cool, so I know what my x is and I know what my y is. Great. That was step 4. Step 5, the most simple answer, or most simple step, is writing your answer as an ordered pair. Remember, an ordered pair is always x comma y. So we're going to write our x first, then our y next. And this is your final answer. 3, 5. We've gone through all 5 steps and we got our final answer. And so if you were to graph these two equations that they gave you in number 3, if you were to graph these two, the intersection point would be 3, 5. Okay, so once again, pause the video if you have any questions and let me know. But other than that, let's try number 4 together. Or actually, why don't you guys pause the video and try number 4 on your own first, and then we'll come back in like 5 seconds. 5 seconds for me because I'm recording. Okay, so hopefully by now you've tried number 4, and let's see if you got it correct or if we still have room to grow, which is totally fine because this is a complicated process and it's brand new to you guys. So no worries if you are still learning it. This is literally your first day doing it. Okay, so let's take a look at the steps. Step 1 says solve one of the equations for one variable. Oh look, it's already solved. So step 1 is done. Step 2, substitute the expression from step 1 into the other equation. All right, so since this is a y equals, I'm going to put it into where the y is. So I'm going to write 6x plus 3. Oh, it says y? I'm not writing y anymore. I'm writing 2x minus 7. And then it's equal to 27. I know a lot of times people forget to finish the equation. You have to still write it's equal to 27, okay? Like you did not finish the equation unless you write equals to 27. So this is a 6x plus 3y is equal to 27. Good. Now step 2 is done. Step 3 says solve for the remaining variable. So what's our remaining variable? Okay, I see an x, I see another x. Oh, x is our remaining variable. Solve. So we got 6x plus distribute. 3 times 2x is 6x. And 3 times negative 7 is a minus 21. And then combine like terms. Oops, that's not equals. And then we're going to add 21. Cancel. And then you just divide by 12 because the x had 12 being multiplied to it. Whenever you don't see a symbol in between here, that just means it's multiplying. So you get rid of that by dividing by 12. Because dividing and multiplying are opposites. Cancel, x is equal to 4. We're not done yet. That was just step 3. Now for step 4, we're going to substitute the results from step 2 into the new equation from step 1 and solve. So we're going to substitute it into this equation. Y is equal to 2x minus 7. I'm just writing it out first. Literally just that equation. And then plug it in for x. 2, not x anymore, x is 4. So y is equal to 8 minus 7 because 2 times 4 is 8. Y is equal to 1 because 8 minus 7 is 1. All right, are we done yet? Nope, that was just step 4. Step 5 is the final. Step 5 says write your answer as an ordered pair. So remember, an ordered pair is always x comma y. So I'm going to do x value is 4, y value is 1. This is your final answer, 4, 1. All right, so please let me know if you have any questions, and if not, oh wait, there we go, we finished step 5. So there we go. Now, let me know if you have any questions. If not, you guys are free to do the skills practice problems. I know it looks different, but it is the skills practice problems. They're just formatted a little differently this time. Let me just briefly talk about them. So for 1 and 2, We're going to write a system of linear equations to represent each problem situation, define each variable, so that's what you're going to do over here. In these boxes, you're going to define what your x and y are. Then you write your equations out, just like write them here. Okay, then you're going to graph the system of equations, so you'll get like 2 lines somewhere, and estimate the point of intersection. You're like, oh, the point's right there. Then you explain what the point represents with respect to the problem situation. So is it like, for example, 5 cats makes 120 dogs? Like, what does that even mean? Okay, so that was kind of covered in our first video. Then if you scroll down, there's more problems of this type. For here, solve each system of equations by substitution. That's what we were doing in this video just now. Determine whether the system is consistent or inconsistent. Actually, I don't think we talked about that yet, so let's scroll back up. Okay, yeah, I totally did not remember this part of the instructions. Determine whether the system is consistent or inconsistent. Okay, so if you end up with a point, this is consistent. This is also, you have a point. It is consistent. I don't know why there's no example for inconsistent, so let me show you other examples. I'm just going to come up with one. Okay, let me see. Y is equal to 3x plus 1. This is my first example. Okay, so for this one, let's do this example. I'm going to do 2 examples with you because I don't know why we didn't have an example for each of these types. So I'm going to do it. Okay, so y is by itself. We're going to plug that into the other equation. I'm not going to write y anymore. I'm going to write 3x plus 1 is equal to, and then finish the equation, 6x plus 2. So instead of the y, I just wrote 2 times 3x plus 1 equals 6x plus 2. So the y got replaced. Then let's distribute. So 6x plus 2 is equal to 6x plus 2. And you're like, that literally just says the same thing on both sides. That's like saying I am equal to myself, right? It's like 6x plus 2 is 6x plus 2. Why am I writing it again? And then the answer to that is because this is the same equation. Because literally 6x plus 2 is the same as 6x plus 2. That means your 2 graphs are going to be on top of each other if you were to plot it out. So let's say one of the lines looks like that. The other line will go directly on top of it. So that means this is infinitely many solutions. So if you're going to have a graph that doesn't come out to one point, but literally it's the same equation because your lines are on top of each other because it has the same equation, then that means you have infinitely many solutions, and remember that this is consistent. Okay? And so instead of having one point as your coordinate, as your answer, you're going to have infinitely many solutions. So this would be the answer for this example that I just came up with. Let's do another example. Let's say we have, I'm just going to use the same equation. Oops. Okay, let's take a look at what happens here. So I have y is all by itself. Actually, y is by itself in both of them. But what that means is I can just take that top one and write 3x plus 1 over here and place it the y. Okay, so literally what I did was I took this number and I just plopped it over here in place of that spot. And the 3x plus 2 is still over here. Okay, so then now it says 3x plus 1 is equal to 3x plus 2. That looks a little bit weird, but let's see if we can work around that. So I'm going to take away 3x. Maybe that will help. Okay, if I take away 3x from both sides, that cancels out. I get 1. If I take 3x away from this side, that cancels out also, and I get 2. Now it says 1 is equal to 2, which is like a lie, because I know 1 is not equal to 2. Cat is not equal to dog. Phone is not equal to computer, right? These are like different things. So this is a lie. So if your equation ends up lying to you, this is no solution. And this, whenever it says no solution, this would be inconsistent. Now, if you were to graph this, if it would just let me write, okay. If you were to graph this, they would be parallel lines. Okay, they will never touch, so they are never going to have an intersection point. So there's no solution, so this is inconsistent. Also, in case you guys ever want to double check your answers, type the equations in Desmos, look for the intersection point, and that will be your double check. All right. So I'm sorry this video went longer than I expected, but I just wanted to make sure you had all the examples necessary. Let me know if you have any questions, okay?